Namaste dear students, I am B.G.Shinde sir and we have started chapter number 3 kinetic theory of gases and radiation, and we have finished the theory topic of this chapter, and we are studying the numericals problems on this chapter. This is lecture number 17. We see the problems which are based on the emissive power and Stevens-Boltzmann law. Now let us see problem number 20. We have completed problem number 19 and 21. Now let us start problem number 20. This is problem number 20 of the textbook. Energy is emitted from a hole in an electric furnace at the rate of 20 watt when temperature of furnace is 727 degrees Celsius. What is area of hole? Sigma equal to 5.7 into 10 raised to minus 8. So here sigma equal to 5.7 into 10 raised to minus 8. It is given watt per meter square degree Kelvin raised to 4. It is given 5.7. Actual value is 5.67, but here it is given 5.7. We take that value. Then P power. This power is 20 watt. Power is given. Then we are given temperature T. This temperature is 727 degrees Celsius. So this is 727 plus 273. So this will be 1000 degree Kelvin. It is 10 raised to 3 degree Kelvin. So convert degree Celsius into degree Kelvin by adding 273. 273 त्याच्यामध्ये ऍड करायचं म्हणजे डिग्री सेल्सिअसचं कन्व्हर्शन डिग्री केल्विन मध्ये आपल्याला करता येतं. त्यानं एवढ्या गोष्टी आपल्याला दिलेल्या आहेत आणि आपल्याला या प्रॉब्लेम मध्ये फाइंड करायचं आहे की व्हॉट इज द एरिया ऑफ द होल. तर एरिया ऑफ द होल काय असेल ते आपण इथे फाइंड करूया. तर आपल्याजवळ एक फॉर्म्युला आहे. R is equal to sigma T raised to 4. हा फॉर्म्युला असतो स्टीफन-बोल्ट्झमन लॉचा. नंतर आपल्याला माहिती आहे की R is equal to Q upon A into T. R Q upon AT. Therefore, this equation will become Q upon AT equal to sigma T raised to 4. You can write this equation as Q upon T equal to sigma A sigma T raised to 4. Now what is Q upon AT? Q upon AT means it is a power. So P is equal to A sigma T raised to 4. This is the formula of the power. You can use this formula directly in exam or in CETs or NEET exams. You should know this for such formula so that you can directly use such formula. You will reduce the time. You can save the time. तर असे फॉर्म्युले आपण डायरेक्टली जर पाठ असले तर एकदम उत्तम राहील. बोर्ड एक्झाम मध्ये चालतात असे डायरेक्टली यूज केलेले आणि नीट सीईटी मध्ये आवश्यक असतं. So A, put value of A. What is area? Area is what is area? Area is to be determined. We determined area. So here determine A. So we determine A. So put value of P. What is P? It is 20. Then area unknown. Sigma 5.7 into 10 raised to minus 8 multiplied by T. T is 10 raised to 3 and it is raised to 4. Now let us find what is A. So 20 equal to A multiplied by 5.7 into 10 raised to 12 and 10 raised to minus 8 will be 10 raised to 4, and therefore A equal to 20 divided by 5.7 into 10 raised to 4. So this is 2 upon 5.7 into 10 raised to 3. It is 2 upon 5.7. This 2 upon 5.7 is 0.3508 into 10 raised to minus 3. Unit is meter square, and this is answer. You can write this as 3.508 into 10 raised to minus 4 meter square. So this will be final answer, 3.508 into 10 raised to minus 4 meter square. So this is answer A area. तर असा हा प्रॉब्लेम आहे. हा प्रॉब्लेम होता प्रॉब्लेम नंबर 20. हा संपूर्ण प्रॉब्लेम आपण देऊन घ्यायचा आहे. आता बघू आपण प्रॉब्लेम नंबर 22. Now in problem number 22 we I will read this problem number 22. Compare the rates of emission of heat by black body maintained at 727 degrees Celsius and 227 degrees Celsius if black bodies are surrounded by enclosure at 27 degrees Celsius. What would be ratio of their rates of loss of heat? असा हा प्रॉब्लेम आहे. स्टीफन्स लॉवर आधारितच हा प्रॉब्लेम असेल, आणि हा प्रॉब्लेम आपण जे गिवन क्वांटिटीज आहेत ते लिहू आणि ते प्रॉब्लेम आपण पूर्ण सॉल्व करूया. सो फर्स्ट लेट अस राइट द गिवन क्वांटिटीज. सो फर्स्ट क्वांटिटी गिवन इज T1. तर T1 ची किंमत इथे दिलेली आहे आपल्याला. सो फर्स्ट वी राइट T1. सो T1 is equal to, this is problem number 22. T1 is 727 degrees Celsius. So this will be 727 plus 273. It is equal to 1000 degree Kelvin. It is 10 raised to 3 degree Kelvin. T1. T2 is equal to 227 degrees Celsius. So this is 227 plus 273. It is 500 degree Kelvin, or 5 into 10 raised to 2 degree Kelvin. Then T0, it is temperature of the surrounding. 27 degrees Celsius is 27 plus 273. It is 300 degree Kelvin. So these three quantities are given, and find the ratio of the rate of emission of the heat by the black body. Now we use Stevens law of addition, and according to that law, R is equal to sigma T raised to 4. Now what is this R? R is radiant energy emitted per unit time per unit surface area. Means we write this as Q upon AT equal to sigma T raised to 4, or we can also write this as Q upon T is equal to A sigma T raised to 4. This is the heat radiated per unit time. It is called the rate of emission. So rate of emission is equal to A sigma T raised to 4. So R is equal to A sigma T raised to 4. we use this formula to solve this problem. So we write here R1 is equal to A sigma T1 raised to 4, R2 is equal to A sigma T2 raised to 4. Therefore, R1 upon R2 equal to A sigma T1 raised to 4 upon A sigma T2 raised to 4, and this is equal to T1 raised to 4 upon T2 raised to 4 equal to T1 upon T2 raised to 4. So R1 upon R2, we get this formula T1 raised to 4 upon T2 raised to 4, T1 upon T2 raised to 4. So let us put the value. So this is equal to, what is T1? T1 is 10 raised to 3 raised to 4. Or we write here 10 raised to 3 and divided by 5 into 10 raised to 2 raised to 4. And so this is equal to 10 upon 5 means it is equal to 2 raised to 4, and this is 16. So R1 upon R2 is equal to 16, and final answer is R1 as to R2 is equal to 16 as to 1. This is final answer. You can put value here 1000 upon 500 raised to 4, and you will get 2 raised to 4 equal to 16. Means it will be simple. So this is answer 16 as to 1. Now we find what is the rate of what is the ratio of their rate of loss of heat. Now we find what is rate of loss of heat. Rate of loss of heat, its formula is equal to its formula is sigma into T raised to 4 minus T0 raised to 4. This is the formula for rate of loss of heat. Now we denote this rate of loss of heat here as some symbol. Let us denote it by R. R is rate of loss of heat, R equal to sigma T raised to 4 minus T0 raised to 4. Now R1 will be equal to sigma T1 raised to 4 minus T0 raised to 4. This is R1, equation 1. Then R2 equal to sigma T2 raised to 4 minus T0 raised to 4. Therefore, R1 upon R2 equal to sigma T2 raised to 4 minus T0 raised to 4 upon sigma T1 raised to 4, T2 raised to 4 minus T0 raised to 4. This sigma will get cancelled. Now put value of T1. What is value of T1? It is 1000 raised to 4 minus 500 raised to 4 divided by, this is 300 divided by 500 raised to 4 minus 300 raised to 4. Now here, these zeros will get cancelled. These two zeros, they are common, and raised to 4 they will get cancelled, and this will be 10 raised to 4 minus 3 raised to 4, 5 raised to 4 minus 3 raised to 4. This will be 10,000 minus 81, and this will be 625 minus 81, and its final answer is found to be 18.23. So this is 18.23, and this is final answer, and that's all about today's lecture. तर हा असा हा प्रॉब्लेम असेल. याचा फायनल आन्सर आहे